Alright, instead of pausing my last video when I couldn't get my calculator to work, I accidentally hit stop. So again, I don't know why it's such a dark screen. But you plug in, so I'm going to plug in negative x plus 3 for the first one, and then x minus 5 for the second one. Make sure I've got a standard window, and I do, so I'm going to go ahead and graph. Alright, so hopefully you can see it. It's a little dark for some reason when it's on my screen. So there's the first line, there's the second line, and so again, they intersect at a single point. So if you look at your graph, go back and look at my graph, they intersect there, and I'm going to find the intersect point, and so I'm going to go to second trace. Alright, 5 is what I want to pick. Intersect. First curve, second curve, guess. So once I get to the, here I should be on one of my lines, I'm on my blue line. And then what you do is you move your cursor over as close as you can to that point where they intersect. It's too far. Alright, hit enter, and then usually it'll pop up on the red line now. It should be close enough, I don't have to move it again. And then guess, same thing. I just usually find it, and so there it is. If you look, it's very small down here, but if you see the x value is 4 and the y value is negative 1, and so it does check my answer. So it did find get it drawn right. They intersect at the point for negative 1, and so it checks, right? I checked my answer. That's the one place where they both share the same point. That's it. They never cross again, and so that is the only solution that's true. And it is the same answer that I got on the previous one. I'm sorry about the split in the videos. I accidentally hit stop instead of pause. Again, I'm using a different program on my phone because I lost the other one. I ran out of it. I didn't feel like buying it again. All right, the last method that you should have learned in an algebra class is the substitution method. Now, this textbook doesn't go over it, and so I'm just going to sort of talk about it. But if you remember the substitution method and you want to use the substitution method, feel free. It's a very good method. It works very well. What you do is you pick one of these equations, solve for a variable. Well, since I've already got them up there and solved for y, the first equation is negative x plus 3. The second equation is y equals x minus 5. And then substitute them in to the other one, all right? So I take the first equation, substitute it in, I get negative x plus 3 equals x minus 5, and then we solve for x. All right, we solve this for x. I move that x over, move that 5 over, and so over here I get 8, over here I get 2, and then I get back to what kind of I started out when we did the elimination method. It's actually the elimination method just done in a different process. It really is that first method, just done in a slightly different process. All right, we get down to the same thing, so we get down to 2x equals 8, which will get me down to x equals 4, and then I substitute it back into one of my other equations, and I'd get x equals negative 1. All right, so that's the elimination method. I mean, that's the substitution method, which, like I said, the book doesn't cover, but if you remember it and you want to use it, it's a perfectly good method. All right, so again, perfectly good method. Graphing is also fine, too. The only catch with the graphing is you always have to set it in the form y equals mx plus b, but again, you could solve it graphically too if you wanted to. We're going to focus on the elimination method, so my next examples are all going to be, so I'm basically going to do one of each of these cases, a one solution, no solution, infinitely many, and I'm going to use the elimination method, right, to finish out this section.